Hello everyone. My name is Shankson Wu. I'm here today to present our paper titled Switchable Representation Learning Framework with Self-compatibility. This paper proposed a learning framework that generates a series of compatible submodels with different capacities through one training process. Here compatible means that such obtained models could interact with each other through their output features. Such a framework enables us to make full use of memory and computing resources on various platforms when deploying a visual search system. The optimization of submodels faces gradients conflict. We mainly tackle such problems from the perspective of the magnitude and direction. There exist many dynamic neural networks that are able to adapt their structures or parameters to the input during inference. Also, many one-shot-based NAS works which can train and optimize subnets with various capacities in one-time training could be compared. Current works focus on classification tasks, detection tasks, and segmentation tasks. Submodels aim to learn better output closer to definite semantic information, like classID or detection box. They do not interact with each other through features. However, as for a visual search system, it recalls the nearest neighbors in gallery features according to their distances to the query feature. It requires compatibility among the gallery and query models to satisfy their interaction requirements, which means that the similar data processed by different models are close to each other in the feature space while dissimilar data are far apart. As for compatible learning works, current researchers focus on backward compatible learning, which aims at aligning the learnable models with a fixed hold one in metric space. Existing methods focus on the optimization difficulties caused by the old model. Different from these one-to-one compatible learning methods, this paper studies a new compatible learning paradigm that aims to learn many-to-many compatibility among multiple learnable models. The framework of our methods is shown in the figure. We first transform the full model into the submodels. Then we calculate the compatible learning loss on different submodels with various capacities. Finally, we optimize the submodels by aggregating losses. As the gradients corresponding to different submodels may have different directions, simply aggregating the gradients by summation may cause mutual interference, as shown in figure. Inspired by gradient-based multitask optimization, we perform gradient projections on conflict pairs to avoid mutual interference and find a generic optimal direction for all submodels. The ablation study shows that our methods have reduced the cumulative number of conflict gradient pairs during the training process. The aggregation method aims to optimize all submodels coordinately. However, it may not work as expected when facing the imbalance of gradient magnitude between submodels, as shown in the figure. Therefore, it is critical to design a compatible loss. Inspired by Dempster-Shafer theory of evidence, we adjust the magnitude of submodel gradient dynamically through uncertainty estimation. We have conducted a gradient analysis for the proposed compatible loss in the paper. And the ablation study shows that our methods ensure co-optimization through uncertainty estimation. We evaluate our method with different loss functions, model architectures and different datasets. We achieve state-of-the-art performance on the evaluated benchmarks. Compared to deploying a unified model, adopting our method to obtain different submodels can achieve 6% to 8% performance improvements on 3 different datasets. In conclusion, in this paper, we propose a switchable representation learning framework with self-compatibility for multi-platform model collaboration. The method enables us to obtain models with various capacities to fit different computing and storage resource constraints on diverse platforms. It learns many-to-many compatibility by uncertainty estimation and gradient projection. Thank you for listening.